Good evening, everyone, and welcome to another live session of Code with Vinay. Today, we'll be talking about primitive values, wrapper classes, types, and casting in Java. Specifically, we'll be talking about the topics mentioned at number 5 of the ISC syllabus of class 11. So, we'll begin with the very basics. So, we are talking about primitive values and we are talking about wrapper classes, and then we'll talk about types and casting. And we'll also be talking about things like NaN, infinity, minus infinity, etc. as well. So let's begin with something simple first. And for that, we'll first talk about why do we call primitive variable a primitive variable. So there are two types of variables basically. One is primitive variable, and the other is, let's say, wrapper types, or you can also say that it is a reference data type. Reference data type. So let's understand the meaning of the word first. So primitive means something which is basic or not very advanced. That's the meaning of primitive. So essentially, primitive variable means that the data is stored inside the variable. For example, if I say that there is a variable int a is equal to 2, then what happens in this case is that computer will allocate 4 bytes, that is the size of an integer variable. The name of that 4 bytes will be a, and the value stored inside will be 2. Now, for the sake of simplicity, I am writing 2. Actually, it is in binary, that is zeros and ones. That's one thing. And in reference data type, what happens is, like, say, for example, if I say integer, that is the wrapper data type, I say integer obj is equal to, again, let's say 2. Then what will happen is that computer will create a reference variable by the name of obj, and then it will point to an area in memory where the data is actually stored along with other things. Now that's the important part, along with other things. So the main thing over here is the actual value, which is in our case 2. So this is the meaning. Primitive variables are basic in nature. They are just a name given to a memory location and you store the value. Whereas the object-oriented version of the same thing is known as a wrapper class. So obviously for each of the primitive data type, there is a corresponding wrapper class. And the extra stuff in the wrapper class is that there are many methods which can be utilized for doing the things. Here, everything is optimized for speed. Primitive means basic, and the good thing about basic is that it is optimized for speed. It is very fast. The problem with integer data, the problem with the wrapper class is it's good because it gives you extra functionality. The con is that it is slightly slower because of the extra stuff. So that's the basic difference between primitive data type and the corresponding wrapper class. So that's one thing. And I hope it's clear to everyone. If there is any doubt, you can leave a message on the comment section, in the comment section, and I'll see to it. So this is one thing. Now, as you can see, there is a list of data types which have been provided. That is byte, int, short, long, float, double, boolean, and char. Now let us discuss these as well. So the thing is, if you want to store a single character, we use a data type known as char. Notice that all the primitive data types start with a small letter. So if I say char ch, computer will allocate 2 bytes in the memory for this character variable. Let's say this is ch. And if I say ch is equal to, let's say, small a, that a will be stored inside the variable ch. one thing to understand is that internally the corresponding Unicode value is stored. That we'll see later after some time, that how we can get the actual value. But for the time being, character variables are enclosed in single quote, and it can be any single character. In fact, if you want to store a single quote within a single quote, you cannot do this. Why? Because computer will think that this is the beginning, this is the ending, and this is just a hanging thing. So this will result in an array. But if you want to store a single character, if you want to store a single quote within a character variable, the correct method is you have to escape it. That is, I'll say slash single quote and then another single quote. So here, this one is the opening, this one is the closing, and this slash single quote is telling the computer that, okay, I want to store the single quote, I am not closing the opening quote. So that's how it goes. So if you have to store a character, we use a character variable. Now, if you have to store an integer, we have multiple options. The options are, smallest one is byte, then we get short, then we get int, and after int we get long. These are the possibilities if you want to store an integer. An integer is a number without a decimal point. So byte, as the name suggests, will occupy 1 byte in the memory. 1 byte is actually 8 bits. Similarly, short will occupy 2 byte in memory, that is 16 bits, and int will occupy 4 bytes in the memory, that is 32 bits. And similarly, long occupies 8 bytes in the memory, that is 64 bits. Now you'll find that in your book they'll give you the minimum and maximum range also. And I'm not a very big fan of memorizing stuff. So what can happen is that I'll tell you how to find the minimum and the maximum value, and then if you can learn it, well and good. It might save some time, but understanding is the main thing. So let me add one more page over here. We'll go to the next page and we'll discuss byte first. But whatever we are talking about byte will be applicable for other integer data types also. And by other integer data types, I mean short, int, and long. So byte is 8 bits in memory, or 1 byte, however you want to look at. So what does 8-bit means? 8-bit means that computer will allocate 8 bits. That is, inside this, there will be 8 compartments. So 2, 3, 4, 5, 6, 7, and 8. There are 8 compartments, and internally these things are like, and the number can be positive, the number can be negative, and 1 bit is utilized for storing the sign of the number. So 1 bit goes for storing the sign of the number in case of a byte variable, and the remaining 7 bits, they are used for storing the magnitude of the number. Now, if you notice, numbers are internally stored in binary. So which means that each of these locations can either be filled with a 0 or it can be filled with a 1. And that applies to all these values, either 0, either 1. That way this will keep on going. So the point is that one place can be filled in 2 ways, 2 places can be filled in 2 into 2 ways, 3 places can be filled in 2 into 2 into 3 ways, 2 into 2 into 2 ways. Similarly, 7 places can be filled in 2 to the power 7 ways. So when there are 8 bits, 1 bit goes for the sign, and the remaining 7 bits are used for storing the magnitude of the number. Now, as you might be knowing, 2 to the power 7 is equal to 128. So there are 120. So if you see the range, okay, let's open JShell so that we can see things in action. So if I open a terminal window and there's a tool named as JShell where we can directly run small codes without writing a full-fledged program. So like this is a JShell. Now see what happens. I'm saying I'll use the corresponding wrapper class to see the maximum and the minimum value. So the data type, primitive data type byte is BYTE is in small case, and I'm interested in the maximum and the minimum value. So there is something known as min value, which will give you the minimum value of a byte variable, which is -128. Similarly, if I say max value, I'll get the maximum value, which will be coming to 127. Now the idea over here is that 2 to the power 7 is 128. Half of those numbers are negative, half of them are positive, but here 0 is counted on the side of positive. That is why the maximum number is going till 127. And the thing is over here, like for example, let me move it over here. Since it is a byte, we are talking about 2 to the power 7. If it's an integer variable, we'll be saying 2 to the power 15. Actual size is 16, 1 for the sign, so you are left with 15. So that's how it goes. So if you want to check, you can always check that 2 to the power size -1 will give you the maximum value, and in the same way minimum value will be without that -1 because of the 0. That's one thing. Similarly, if I say integer dot max value, I'll get the maximum value of an integer, which is this. And in the same way, I can say min value for the minimum value as well. Now, this is how the calculations go, so that you don't have to memorize the values of so many numbers. But yes, if you want to check, we can always check that our calculations are right. Let's do it for integers for the sake of practice. So this is the range. Now I'll open a binary calculator in Linux and let's do some direct calculation. So in case of integer, the size is 2 bytes or 16 bits. 1 bit is for the size, remaining bits are 15. So the value of 2 to the power 15 is 32768. Sorry, I made a mistake. The size of an integer variable is 4 bytes. 4 byte is 32. So 2 raised to the power 31 is equal to 21478333648, which is same as the negative value, and obviously -1 will give you the maximum value. So there is no need to memorize. In exams, if you have to write it, you can say 2 to the power 31 -1 and you will get your marks. Okay, so that's one thing. Now, another thing which I would like to discuss is that what can you store an integer variable? So please just pay attention. I'll just close this portion. This is not really required. And I'll clear the screen as well. Now notice what I'm doing. If I say int a, my variable is an integer variable. Initial value is 0. If I say a is equal to 2, the value stored is 2. But if I say a is equal to 02, that is, I'm starting the constant with a 0, it becomes an octal number. Now here it's not making a difference, but notice if I try to say 08, please understand octal numbers are from 0 to 7. 8 is not a valid octal number. So if I press enter, you get an error, integer number too large. The idea over here is that since the number is starting with a 0, computer is treating it as an octal number. Octal number must consist of digits from 0 to 7. You cannot use a digit more than 7 in a octal number. Similarly, if you want to represent a binary number, I can say a is equal to, and we start it with 0b. So for example, if I say 0011, this is actually equal to 3. 11 in binary is 3. Similarly, if I say 111, it becomes 7. So that's the idea. So if an integer is starting with 0b, it is binary. If it is starting with 0, it is octal. If it is starting with 0x, it becomes hexadecimal. Like say, for example, I say that, okay, A is equal to 0x and then I follow it by A. If I press enter, you'll see it is equal to 10. Similarly, if I say F, it is 15. So that's how numbers are interpreted. So don't think like in normal maths, you say, whether you say 0, 0, 7 or 7, it means the same thing. It's not the same thing when you are working in the Java programming language. These things are different due to the syntax. Okay. This is one thing which I wanted to discuss, how to store integers. Now, if I go back to the last screen, so these are the data types we have for integer: byte, short, int, long. Which one to use depends on how big or small your number is and how sensitive you are about the space used. But normally when we are using an integer, we use int because the size of the int is usually optimized in all the languages. So unless and until you want to store a very big number, you won't go for a long. And unless and until you are running very short on space, you probably won't take a byte or a short. So normally when we say int, we are using the variable int and not byte, short or long. That's one thing which I wanted to discuss regarding the integer data type. Now, I've told you that character variables internally store a number. Like for example, if I say char ch is equal to a, please remember the code for a is 65. So it is saying ch is equal to a. I could say that, okay, ch is equal to 65. And again, I press enter. And as you can see, the value stored is still a. And that's why it is possible to do things like ch plus plus. 65 plus 1 is 66. But since it's a character variable, the value stored will be, wait, I have to say ch is equal to ch plus 1. But now please understand, it is a mixed data type. So the type of ch is character, the type of 1 is an integer. And whenever you are having a mixed expression, that is, you are having both, let's say in this case, a character and int, the final result will be of the highest data type. So character plus integer will give you integer. The variable on the left hand side, that is ch, is a character variable. That means this is not going to succeed. If I press enter, see what happens. It says incomparable types, possible lossy conversion from integer to char. So an integer cannot be stored in a character variable. And here we come to the next topic, that is typecasting. If you want to store a bigger data type into a smaller data type, you have to convert it explicitly, and that is something known as explicit typecasting or just simply casting or typecasting. So if I say over here char, now see what happens. Computer will convert this into a character variable, and now you can see that c is getting stored. How come c? It was 65. I said plus plus, it becomes 66, and then I said 66 plus 1 and it became 67, which is C. So these two are interchangeable. In fact, if I go the other way around, like for example, if I say int C is equal to, and then within brackets, I say A. Notice what is happening. The variable on the left side is integer. What I am storing on the right hand side is actually a character, but since the variable on the left hand side is an integer is a bigger data type than a character, computer will store the code of A. So if I press enter, the value stored is 65. And like for solving multiple choice question and all, it is better if you remember the first few values. Like for example, the values worth remembering are, like for example, if I say ch is equal to A, you already know it is 65. Similarly, z is 90, small a is 97, and small z is 122. So if you are trying to store a smaller data type into a bigger data type, computer does the conversion automatically. That is something known as automatic type conversion. But if you are trying to store a bigger data type into a smaller data type, you have to convert it explicitly by giving the type inside the parenthesis like we are doing over here. One more thing which I would like to emphasize at this point of time is that if you have, like for example, I'll show you with the help of example. Suppose I say 5 by 2. Now please notice over here, 5 is an integer, 2 is an integer. Integer divided by integer will give you an integer. So the answer won't be 2.5, it will be simply 2. So that is something very important. Be very careful about this. You might see, like for example, even if I say 5 divided by 2 into 10 point, or let's say into 1.0. So if I press enter, see what happens. It says 2.0, it is not saying 2.5. Why? Because again, integer divided by integer is still an integer. So 5 by 2 is 2, and then 2 into 1.0 is 2.0. So be very careful when you are having a mixed expression. Like say for example, if you are finding out some percentage, let's say the variable is, let's say rate. So rate divided by 100 into something. Now the problem is, rate, if rate is an integer, rate divided by 100 is still an integer. So this will result in automatic truncation and you will lose data. So the better way is either you say that one of them is double or a float, and then you won't lose the precision, and that is something very important. Okay, now let's say one more thing which is very important, and that is division by 0 is not allowed. Like for example, if I say 5 by 0, you will get arithmetic exception. But please note, if I say 0 by 0, then this cannot be done in maths. So what cannot be done in maths cannot be done over here also. So if I say 0 by 0, here also you are getting arithmetic exception because you cannot divide by 0. And later on when we'll discuss float and double, we'll see that there the scenario is slightly different. So right now we were talking about integers, and whatever we are talking about int will hold for byte, short and long as well. Now if you want to store a fractional number, you'll either use a float or a double. The difference is that float takes 4 bytes and hence the range is smaller than double, which takes 8 bytes in memory. So if I say float a is equal to 2.5 and I press enter, you'll see that it is again saying incompatible type, possible lossy conversion from double to float. So the idea is, if you use a decimal point, computer treats it as a double. So if you want to say that, okay, this is not double but float, what you have to do is you'll have to say a small f over here, and you can also say a capital F also. That means the same thing. So if you want to explicitly represent a floating point value, you'll have to use the suffix small f or capital F. If you are using a double variable, you can do it directly. Like for example, if I say double D is equal to 2.5, now there is no need to explicitly say D for double, but if you want, you can say D for double and the program is still going to work. And obviously you are allowed to use the small d as well as the capital D to denote a double value. I hope this is clear to everyone. Now this is a very simple thing. Now let us discuss something complex in nature, and that is float and double are both what you call, they are not accurate. They are correct to a certain number of places and they cannot store all the possible values. Like for example, if I have a floating point variable f and I say float f is equal to 0.03 and I press end, sorry, I forgot the f, and I say press enter, you are seeing 0.03. Now if I say 0.03 f plus, sorry, 03 f plus 0.03 f plus 0.03 f and I press enter, see we are not getting exact 0.09. The reason is that 0.09 cannot be expressed exactly in a float variable. So both float and double are always approximate in nature. This is a very important concept. Float and double are approximate in nature. You will get a value which is very close to your value, but it won't be exactly that value. I hope this makes sense. Another point I would like to emphasize over here is that if I say 5 by 0, you get division by 0. But if I say 5.0 divided by 0.0, or let's make it simple. If I say 5 divided by 0.0, notice what happens. You get infinity. That is, if you divide by fractional 0, or I can even say 5 divided by 0f, it means the same thing, we'll get infinity. Similarly, if I say minus 5 divided by 0f, I'll get minus infinity. So that's a very important concept. Don't think that integer and float behave the same way. There is a slight difference over here. So infinity and minus infinity, what are these? These are also actually constants defined within the float class. One for plus infinity, one for minus infinity. And there is one more thing, like if I say 0f divided by 0f, and the same will hold for 0d divided by 0d, I press enter, you get NaN. Now what is NaN? NaN stands for not a number. Now please note, it's not an error, it's not an exception, it is something, it is actually a constant defined in both the float class and the double class. Like, just give me a moment, I'll pull up the documentation page for double. So see, this is the documentation page for double, and if you see clearly, it clearly says a constant holding a not a number value of type double, it is equivalent to the value returned by long bits to double. That is, this is the actual value which is stored inside the variable NaN. It's not an error, it's actually a constant which is defined in float and double. In fact, if you want, you can say that, okay, float dot NaN, and if I press enter, see, it displays as NaN, which means that it's actually a value. Now, what does it mean? This is something very important. What does NaN mean? So NaN usually indicates the result of invalid operations. For example, if I am dividing by 0, that is one such case, like I did above. So 5 0 by 0 is NaN. That is one case. There can be other things also, like in this case, it is the result of an invalid operation. The other possibility is we can also use NaN for unrepresentable values. Like, say, for example, if I try to find the square root of -1. Now, the square root of -1 cannot be found out. It does not exist. You can say that it is a complex number, but then complex number cannot be stored in a floating point variable. So like, for example, if I say math dot square root, let's say -25. If I press enter, I'm getting NaN, which means that the answer cannot be represented in this double value. Math dot sqrt represents a double. So this is one thing. Another interesting point is that any operation involving NaN is actually false. Like, for example, if I try to multiply, divide, or do something of that stuff, like, for example, if I say is NaN is equal to, let's say, 1. Sorry, what I did, I cannot say NaN like that. I have to say float.nan or double.nan, because inside this there is no NaN. So see, float.nan is not equal to 1. If I say that, okay, is it more than 1, even that is false. If I say is it less than 1, even that is false. So any operations involve any comparison with NaN will always give you NaN, but there is one exception, and that is quite interesting. If I say float.nan, and see, what I'm doing is not equal to float.nan. That's the only case in which we are going to get a true. So it's not that one nan is what you call a number. It's actually a symbol which is denoting it's not a number. And once in an expression you reach a stage where it's not a number, then obviously you cannot get a number back. It will always be nan. So these are some what you call edge cases or corner cases which you must know. And obviously if I try to do any other operation, like say for example if I say float.nan plus 100, I'm still going to get a nan. So once you get a nan, it remains an nan. And if you are getting an nan in a mathematical expression, it usually means that you have some sort of logical error in your program. Otherwise, you're not supposed to get a nan unless and until, like we are doing over here, we are trying to show what is an nan and we are getting it purposely. So that's another point which I would like to emphasize. Now let me get to the symbol again. Syllabus again to see what are the other topics mentioned. So we have talked about wrapper classes. Now class as a type of object and class as mechanism for user defined types. Now this is actually quite a big topic and we'll be discussing it in detail when we reach the later parts where we will be talking about constructor and all. But here what we are trying to say is, let's say you have to store something which is not of one of these type. Like say for example, if I have to store in which class you are studying, you'll probably say 11th A, 11th B. So basically this has two parts. There is one standard, the number, and then there is one section. So if you want to store such a value inside your program, you can use a class, and within that class you can have two data members. Similarly, if you want to store a fraction, there is no way you can store the numerator and denominator separately. But if you want to store it as a data type, what you can do is you can create a class fraction which can have two data members, one for the numerator, one for the denominator, and then we can define other methods for doing, let's say, addition, subtraction, multiplication, division, etc. So that's another point. And then changing types through user-defined casting that we have already discussed. One thing which we haven't talked about is boxing and unboxing. Let's discuss what it is. So I told you that for every primitive data type, there is a corresponding wrapper data type, which is the object version of it. So if you are converting a basic data type into an object like we are doing over here, integer obj is equal to 2, this is known as boxing. And if you take out the value by using the value of method, then it is known as unboxing. So that's the meaning. I'll just show you for the sake of completeness. So let me clear the screen. I create one variable. I say integer, and what to call it? Let's say my integer, and I say that this is equal to 5. So here 5 is our primitive integer value. I'm trying to convert it into its corresponding object type, and this is something known as boxing. The idea of saying boxing is that we are putting it inside a box, we are putting it inside an object, and hence this is known as boxing. The reverse of this is known as unboxing. Like for example, if I say int my value is equal to, and I say my int dot int value, and I press enter, see, we are getting the value 5 back, and this thing is known as unboxing. So with this, we have covered all the topics mentioned in the syllabus regarding primitive values, wrapper classes, types, and casting. Now, obviously, these things will keep on coming back in different forms when we'll move on to later topics. But today's agenda was only about point number 5, and we have covered all these things which are defined over here. Now it's the time for Q&A session. So if you have any doubts, you can post it on the chat and I'll answer it. Okay, it seems that the topic is clear to everyone. So we'll stop over here. And in the next class, we'll be talking about point number 6, that is variable and expressions. And here also we'll be doing some deep diving. We'll see some edge cases like we did today about NaN, infinity, etc. So we'll meet in the next class. Till then, happy coding.